In this video, we're going to focus on multiplying a monomial by a polynomial. Before we get started, it's important to remember the exponent laws we learned in Unit 3. The product rule, the quotient rule, the power rule, and the zero rule. These are going to come in handy as we start multiplying different variables. We also need to remember the skills we learned in Unit 4 about distribution. In the example here, I have two monomials that are multiplying each other. I can rewrite the expression like this. Remember from when we learned multiplication that as long as everything is multiplying together like we have here, we can rearrange the order in how we write things. So I'm going to rearrange this and put like bases together. I haven't changed the question here. I've just rearranged the order that I wrote the terms. And so what this allows me to do is use the exponent rules as well as some multiplication to simplify these terms together. I know what 4 times 2 is. I know what x squared times x is because I can use the product rule. I also know what y times y cubed is, again, because of the product rule. Whenever we have the same base, the exponents will add. So simplifying, 4 times 2 is 8, x squared times x is x to the 3, and y times y cubed is y to the 4th. This is an example of a monomial times a monomial, one term times one term. We are grouping the coefficients and we are grouping the like bases together and using our exponent rules to simplify. Example 1 is an example from our Unit 4. We have just a constant out front, and in order to simplify, all we need to do is distribute. Because the constant does not have any letters, nothing changes other than the coefficients. So simplifying would look like this. I have just a number out front, so when I multiply, I'm multiplying just the numbers, and I don't touch the variables. In example 2, we have a monomial. Now I have a coefficient and I have variables. So when I distribute, I need to group the variables together. When I distribute a monomial times a binomial, whatever's in the front has to multiply everything inside. So this ends up being 2 monomials multiplying together. And I'm going to follow the example that I did in the previous slide. I group the numbers together and I group similar bases together. If there is no other similar base, so for example in the second term, the 5 doesn't have any variables, then I just multiply the numbers together and I leave the variables as they are. So my next line would look like this. In my first term, the 2 and the 3 make a 6. My x and my x squared give me an x cubed. And I don't have any more y's here, so the y squared just stays y squared. So these two simplify to that. Same thing with the second term. The numbers go together to make a 10, and since there's nothing here for variables, whatever I started with, I don't change. So this is my final answer. In example 3, again, I have a monomial times a binomial. I need to distribute to both terms. And when I'm multiplying, I am grouping like terms or like bases together. The numbers go together, same bases go together, and anything that doesn't have a partner just stays by itself. So the first term gives me 12a cubed b, and the second term gives me 16, no a's in the second part, so this is just a squared, and then b times b gives me a b squared. And that is my final answer. Writing this step is optional, but it is very helpful to see which terms need to go together. If you are able to go straight from this step here, that's great, but if you're struggling with getting the right answer, then this step is really helpful. Example 4 gives us a slightly more complicated example because now we have some positives and negatives inside and outside the bracket. I also have a monomial on the outside and a trinomial on the inside. So when I distribute, I have to do it 3 times. Here you'll notice some double symbols. Whatever the symbol is in front of the coefficient, I wrote in the front first, and I left the -5 together. What I mean by this is this was a positive 3xy times a -5. So there's an imaginary positive sign here, and then a -5x cubed. In the second, we have a positive 2. So I wrote the positive sign, but because 5 is negative, I wrote the -5 beside it. So I have a double negative here, a double symbol here that I'm going to need to simplify. And again, in the back, I have a -x. So the negative is first, and then the -5 after. So I have 2 symbols here. So be careful with your positive and negative signs. Make sure you're simplifying those as you go. And some of you might be able to do this in your head, which is great. But if not, write it out and make sure you're simplifying. My first term is going to be negative. My second term is going to be negative, because positive and a negative make a negative. And my third term is going to be positive. Now I need to just put the numbers and letters together. Putting everything together gives me this as my final answer. In example 5, I'm going to simplify, but I'm going to skip writing the middle step. I'm just going to point out how I'm deciding the sign by looking at the coefficient. -3, -2, that's going to give me a positive number. -3 positive x, that's going to give me a negative number. -3 -4, that's going to give me a positive number. So let's distribute and simplify in one step. Paying close attention to the coefficients and using our exponent laws, this is my final answer. In our last example here, we are looking at dividing polynomials, or in this case, a monomial. The same methods apply as before. When we were multiplying, we grouped the numbers together, which we will do here. We then grouped like bases together. So the x's will go together and the y's will go together. So we're going to use a combination of our quotient rule and some algebra. 32 divided by 8 is 4. Using the quotient rule, x to the 5th divided by x to the 4th is x to the 1, or just x, right? 5 minus 4, top minus bottom. And lastly, y squared. This is my answer. We'll talk more about dividing polynomials in the next couple of lessons. Thank you for watching. Don't forget to subscribe and click on the next video.